Have you ever looked up at the night sky, feeling the profound silence of the stars, and wondered if the reality we perceive is merely a gentle illusion hiding a much grander, infinite truth? We live our lives bound by the familiar rhythms of day and night, walking upon the solid ground of our small, rocky world. Yet we are suspended in a cosmos so vast that our human minds truly struggle to comprehend its authentic scale. The universe is not what you might think it is. It is not a quiet, static tapestry, woven merely for our simple viewing from below, but rather a dynamic, ancient ocean of mysteries that challenges our very definition of existence and origin. When we ask about the ultimate nature of reality, about the profound forces that shape creation, concepts some throughout history might call the divine, we are essentially seeking to understand the architecture of the infinite. It is a quest that brings us face to face with the mystery of our own insignificance and the gentle wonder of our consciousness. Before we delve deeper into this ocean of stars, let me formally welcome you. I am Theodore, the researcher, your gentle guide on this journey through the cosmos. I have noticed that 71% of the beautiful, curious souls who watch these videos have not yet subscribed to our channel. If this quiet exploration of the universe brings you a sense of peace and intellectual safety, I warmly invite you to subscribe. It helps us tremendously and ensures that we can continue to share these meditative cosmic journeys together, exploring the unknown as a community of learners. Now, let us return to the deep silence of space and the profound mysteries it so patiently holds. Let us breathe in the calm of the night and begin to peel back the layers of the reality we thought we knew. To begin to grasp the true nature of the cosmos, we must first look at our own home, the Milky Way. Our home is what scientists call a barred spiral galaxy, a magnificent structure with beautiful curving arms composed of stars, gas, and dust, all swirling around a central bulge where an enormous black hole sits in quiet dominance. From one edge to the other, our galaxy measures roughly 100,000 light-years across. That means if you could somehow travel at the exact speed of light, which is the absolute fastest anything can move in our universe, it would still take you 100,000 years to cross from one side of our galactic home to the other. That span of time is almost impossible to truly internalize. 100,000 years is vastly longer than modern humans have even existed upon the earth. It is an expanse of time far longer than the era since we first learned to paint our stories on the walls of caves. It outlasts every single civilization that has ever risen, flourished, and fallen on our fragile planet, all combined into one fleeting breath. And yet, that incomprehensible distance is merely the width of our own little familiar corner of the cosmos. The Milky Way is a sanctuary to somewhere between 200 billion and 400 billion stars. Each of those glowing embers might have planets orbiting around them, moons circling those distant planets, wandering asteroids tumbling endlessly through the cold space, and comets streaking through the dark, silent void. Our sun is just one of those hundreds of billions of stars sitting about 26,000 light-years from the galactic center in a quiet, unassuming neighborhood called the Orion Arm. Our sun and its entire family of planets orbit the center of the galaxy at a speed of about 500,000 miles per hour. Even moving at that tremendous velocity, it takes our solar system about 250 million years to complete a single lap around the galactic center. Astronomers sometimes call this immense period a cosmic year or a galactic year. In the entire duration that giant dinosaurs roamed the surface of the Earth. Our solar system did not even manage to complete one full orbit. The last time our sun was in roughly this current position in the galaxy. The most complex life on Earth consisted only of simple marine organisms floating in ancient oceans. That is how vast even our own galaxy truly is. Yet, the space between the stars in the Milky Way is almost unimaginably empty. Our nearest stellar neighbor, a small red dwarf star called Proxima Centauri, is about 4.24 light-years away. That distance is so exceptionally great that if you were to shrink our sun down to the size of a single grain of sand, Proxima Centauri would be another tiny grain of sand sitting about 4 miles away. The space stretching in between those two grains would be essentially a complete void, containing just the faintest whiff of gas and dust and the occasional solitary particle of cosmic radiation. This profound emptiness is very hard for us to wrap our minds around. We live on a densely crowded planet, continually surrounded by billions of other people, constantly sharing our space with countless other living things. We are completely used to density, to things being physically close together, to the world feeling fundamentally full. But step outside the boundaries of our solar system, and pure emptiness becomes the absolute rule. Stars are separated by such vast gulfs that the chance of any two of them colliding by sheer accident is essentially zero. Entire galaxies can pass straight through one another without any of their individual stars actually hitting one another. Yet somehow, even in all that endless emptiness, there is enough material out there to forge hundreds of billions of stars in our galaxy alone. When you step outside and look up at the night sky from a truly dark location, that hazy, ethereal band of light stretching far overhead is actually the combined glow of billions upon billions of distant stars residing within our own galaxy. Ancient people looked upon it and thought it looked like spilled milk flowing across the heavens, which is precisely where the name Milky Way originates. For the vast majority of human history, we simply assumed that this glowing band was everything. We honestly thought our galaxy was the entire universe. Different cultures around the globe had different beautiful explanations for that celestial band of light. The ancient Greeks told compelling stories of milk spilled from the goddess Hera's breast. The Romans referred to it as the Milky Road. In India, it was reverently seen as the sacred path souls take on their quiet journey to the afterlife. Aboriginal Australians envisioned it as a majestic river flowing in the sky. People throughout all of recorded history have looked up at that very same band of light and wondered with deep curiosity what it might truly be. When the very first primitive telescopes were finally turned toward the Milky Way in the 17th century, awestruck observers began to realize that the milky glow miraculously resolved into countless individual stars. This incredible realization was merely the very first hint that our galaxy was far larger and contained far more stars than anyone had ever dared to imagine. However, it was not until the 1920s that an astronomer named Edwin Hubble definitively proved that those fuzzy, indistinct smudges people had been observing through their telescopes were actually entire, separate galaxies themselves. Each one of these distant smudges contained billions of their own shining stars, and each one was impossibly far away from us. That single, monumental discovery changed absolutely everything we thought we knew about our humble place in the cosmos. Hubble made this paradigm-shifting discovery at the Mount Wilson Observatory, located in California, using what was, at that time, the largest telescope in the entire world. A powerful reflector with a massive mirror measuring 100 inches across. He was patiently observing a specific class of stars called Cepheid variables within what was then referred to as the Andromeda Nebula. These fascinating stars naturally pulse in brightness with a very regular period. By carefully measuring their apparent brightness and their steady pulsation rate, Hubble could mathematically calculate just how incredibly far away they were. The Andromeda Nebula was not simply a small cloud of gas floating within our own galaxy, as many prominent astronomers of the day had confidently assumed. It was roughly 1,000,000 light-years away, residing far beyond the outermost edges of the Milky Way. It was an entirely separate, magnificent galaxy, a majestic island universe of stars existing in its own absolute right. Our galaxy was definitively not the whole cosmos. It was merely just one single galaxy existing among countless many. We now understand through modern science that Hubble's original distance estimate was actually off by about a factor of 2. The Andromeda Galaxy is currently known to be about 2,000,000 light-years away from us, not just 1,000,000. But his basic, groundbreaking conclusion was absolutely correct. The universe was vastly, incomprehensibly larger than anyone had ever imagined, completely filled with countless galaxies, each one containing billions of unique stars. Today, modern astronomers estimate that there are around 2 trillion individual galaxies in the observable universe. 2 trillion is a 2 entirely followed by 12 zeros. Each of those 2 trillion galaxies contains billions or even trillions of its own stars. The numbers become so staggeringly large that they simply stop meaning anything logical to our limited human brains. They invite us to let go of our need for complete control and simply surrender to the awe of the infinite. This profound realization is just the beginning of our path. The truth of what lies in the deep dark, waiting for our telescopes to find it, is a story that will challenge everything you think you know about how large things can truly get. As we drift further into the infinite expanse, we realize not all galaxies are created equal in this cosmic ocean. Some are tiny dwarf galaxies holding just a few billion stars quietly floating like gentle islands. Others are massive spirals like our Milky Way or our neighbor Andromeda, adorned with curving arms where stellar nurseries bloom. These spirals are beautiful sites of active star formation, with new stars continuously born in the gas-rich arms. This magnificent structure is delicately maintained by a balance between the rotational motion of the flat disk and the gravitational pull of matter held within. But the cosmos also crafts elliptical galaxies, which are another major type altogether. Unlike the swirling spirals, these ancient galaxies possess no particular structure. They range from nearly spherical shapes to elongated oval forms, populated mainly by old, slowly cooling red stars. Star formation has largely ceased, as they have exhausted almost all of their primordial gas over billions of years. The largest galaxies in our universe are almost all elliptical, slowly formed through the quiet merger of multiple smaller galaxies. There are also irregular galaxies floating in the void, which have absolutely no defined shape at all. These are very often the chaotic result of gravitational interactions with nearby galaxies, which have distorted their original structures through the silent tug of gravity. The Magellanic Clouds, visible from the southern hemisphere, are wonderful examples of irregular galaxies currently being affected by the Milky Way's immense gravity. Yet, in this vast meditative journey, we must recognize that galaxies are not distributed randomly through the endless space. They are intricately organized into much larger, more profound structures. Galaxy groups typically contain anywhere from a handful to a few dozen galaxies. Our own Milky Way belongs to the local group, containing roughly 80 known galaxies, beautifully including Andromeda and several dwarf galaxies. As we step back further, we find galaxy clusters containing hundreds to thousands of galaxies intimately bound together by gravity. The largest structures of all are superclusters, vast assemblages stretching across hundreds of millions of light years of the quiet dark. Sitting at the extreme end of this cosmic scale, hiding in the dark, are the true giants of the universe. There are galaxies so enormous that they make our Milky Way look like nothing more than a tiny speck of dust floating aimlessly in an empty warehouse. The galaxy I want to guide your mind toward today is one of those breathtaking monsters. It goes by the somewhat boring name of IC 1101, which comes from its entry number in a catalog of celestial objects created over a century ago. But please, do not let that dull name fool your imagination. There is absolutely nothing boring about this ancient cosmic giant. IC 1101 sits quietly at the very center of a massive cluster of galaxies called Abel 2029, located in the direction of the constellation Virgo as seen from Earth. When astronomers point their most powerful telescopes towards this region, they see a massive collection of galaxies, all bound together by gravity, eternally dancing around a common center. Right in the deep heart of that vast cluster, dominating absolutely everything around it like a silent emperor, sits IC 1101. This majestic galaxy is meticulously estimated to be somewhere around 4 to 6 million light-years across. I invite you to pause, breathe, and let that staggering measurement sink into your consciousness. Our Milky Way, which already seemed impossibly large, is only about 100,000 light-years wide. IC 1101 is roughly 40 to 60 times larger than our entire home galaxy. If you placed IC 1101 exactly where our Milky Way currently sits, it would swallow our entire cosmic neighborhood without a sound. The mighty Andromeda galaxy, sitting about 2.5 million light-years away from us, would suddenly find itself lost inside IC 1101's massive body. The Triangulum galaxy, another close neighbor of ours, would also be consumed. All of the dozens of smaller dwarf galaxies that patiently orbit us, like the Large and Small Magellanic Clouds, would become tiny components of this giant's unbelievably vast structure. Physical size is truly just the beginning of the profound mystery of what makes IC 1101 so breathtaking. This ancient galaxy is estimated by scientists to contain around 100 trillion individual stars. 100 trillion. To place that into a gentle perspective, the Milky Way has maybe 400 billion stars at most. That astronomical difference means IC 1101 possesses roughly 250 times more stars than our home galaxy. Let us engage in a quiet thought experiment to truly feel the weight of this infinite wonder. If you somehow started counting the stars in IC 1101, exactly 1 star per second, without ever stopping, it would take you over 3 million years just to count to 100 trillion. And that is operating under the impossible assumption that you never slept, never ate, and never took a single break of any kind. For over 3 million years, you would be doing nothing but speaking the numbers of stars, while the quiet universe marched slowly on. The fascinating story of how human beings discovered this cosmic giant begins long ago, back in the year 1790, when a brilliant astronomer named William Herschel was systematically scanning the night sky. Herschel was unquestionably one of the greatest astronomers of his specific era. He had already discovered the planet Uranus several years earlier and dedicated his life to cataloging thousands of celestial objects. On June 19th of that year, Herschel pointed his telescope toward a dark region in the constellation Virgo and softly noticed a faint, fuzzy blob of ancient light. He carefully recorded its position and quietly moved on to the next object in the dark. At that precise time, Herschel had absolutely no way of truly knowing what he was actually looking at. The technology simply did not exist to accurately measure exactly how incredibly far away this object was. The scientific understanding did not exist to recognize that it was an entire galaxy completely separate from our own. Herschel simply logged it as another unknown nebula, merely one of many mysterious, cloud-like objects scattered across the heavens. For over a full century, that very faint smudge of light remained a profound, quiet mystery. It was eventually given the designation IC 1101 when it was included in a catalog called the Index Catalog, an expansion of an earlier list. Astronomers studied it when they could, but without the tools to understand its true nature, it remained just another entry in a long list of cosmic curiosities. Everything fundamentally changed in the 20th century when astronomers developed better telescopes and entirely new techniques for measuring distances. They finally discovered that IC 1101 was absolutely not a cloud of gas within our own galaxy. It was an entirely separate galaxy, mind-bogglingly far away in the deepest dark. The gentle light we observe from IC 1101 today left that ancient galaxy over 1 billion years ago. That means its photons have been continuously traveling through the silent void of space for more than 1 billion years, just to softly fall upon our waiting telescopes. Let us pause to contemplate that enormous span of deep time. When that light began its incredibly long journey toward us, life on Earth was still mostly composed of simple, single-celled organisms resting in primordial waters. Complex animals had not yet even begun to evolve. The giant dinosaurs would not actually appear on Earth for another several 100 million years into the future. Every single major event in all of human history, from the rise of the first early civilizations to the remarkable invention of the telescope itself, all happened while that ancient light was still silently crossing the unfathomable emptiness between the galaxies. As astronomers continued to study the ancient light of IC 1101, they began to slowly understand exactly why it was so incredibly massive. This majestic galaxy did not simply grow to its enormous size through normal, gentle processes alone. It became a staggering giant through an act of cosmic violence that has been silently happening for billions of years in the deep dark. In the vast cosmos, IC 1101 is what scientists call a cannibal galaxy. It has been quietly eating other galaxies. To truly understand galactic cannibalism, we must pause our journey and think about how gravity works on the absolute largest scales of the universe. Galaxies do not exist in pure isolation. They are grouped together in massive clusters, held intimately together by their mutual gravitational attraction. Within these colossal clusters, galaxies continuously move around each other in a slow, ancient dance, sometimes passing close by, sometimes colliding directly. When two galaxies get exceptionally close to each other, the invisible tether of their gravity begins to deeply distort their delicate shapes. Stars that were once safely orbiting get pulled out of their normal paths, drifting into the unknown. Clouds of gas and cosmic dust get compressed and stretched across the infinite void. If the two interacting galaxies are relatively similar in overall size, they might gracefully merge together over hundreds of millions of years, eventually forming a single, much larger galaxy. But if one galaxy is vastly bigger than the other, something entirely different happens in the silence of space. The profoundly larger galaxy simply absorbs the smaller one, gently stripping away its stars and its gas and silently adding all of that ancient material to its own massive body. This is exactly what has been happening to IC 1101 for billions of years. As the absolute largest and most massively dominant galaxy in its entire cluster, IC 1101 sits regally at the gravitational center of everything around it. Smaller galaxies that mistakenly venture too close get hopelessly trapped by its enormous, inescapable gravity. They slowly spiral inward, getting quietly torn apart and completely consumed over millions of years. Each cosmic meal makes IC 1101 a little bit bigger, a little bit more massive, and a little bit more dominant in the dark. Scientists carefully estimate that IC 1101 has undergone at least 76 major mergers over its long, unfathomable history. 76 distinct times another substantial galaxy fell helplessly into this cosmic giant and was entirely absorbed into its vast body. And those are truly just the major mergers. Countless smaller dwarf galaxies have also been quietly consumed, galaxies so small that they barely registered as a fleeting meal for this enormous ancient predator. The undeniable evidence for this cannibalistic history is beautifully written in IC 1101's very physical structure. When you look at a vibrant galaxy like our Milky Way, you see a wonderfully beautiful spiral pattern. Those iconic spiral arms are dynamic regions where stars are actively forming, where immense clouds of primordial gas are gently collapsing under gravity to create brilliant new stellar nurseries. Spiral galaxies have rich abundances of gas and dust, the essential raw materials fundamentally needed for star formation, and they possess a very distinct, flat, rotating disk shape. IC 1101 looks absolutely nothing like this familiar home of ours. It is what astronomers call an elliptical galaxy, which means it has a remarkably smooth, oval-shaped appearance, with absolutely no spiral arms at all. This smooth shape is a profound testament to its chaotic past. Elliptical galaxies beautifully form when delicate spiral galaxies violently merge together. The immense gravitational interactions during a massive merger completely destroy the delicate, swirling spiral structure, irreversibly mixing all the billions of stars together into a much more random, spherical, or elongated oval distribution. The fundamental fact that IC 1101 is such a smooth elliptical galaxy tells us with great certainty that it has experienced so incredibly many mergers that any original spiral structure it might have once possessed has been completely and forever erased. All of those ancient collisions, all of that immense gravitational chaos happening in absolute silence, has stirred up the trillions of stars like someone slowly mixing ingredients in a gargantuan cosmic bowl. What remains today is this smooth, beautifully featureless giant, a quiet monument to billions of years of endless galactic consumption. But as we drift deeper into this mystery, there is something even more remarkable about IC 1101. Despite containing an unfathomable 100 trillion stars, it is actually a slowly dying galaxy. The stars within its vast body are almost all incredibly old. Most of them are what astronomers gently call red giants or yellow stars, ancient stellar objects that have already burned through the vast majority of their life-giving fuel. Very few new stars are ever being born inside IC 1101 today. This profound realization might seem incredibly strange to you at first. With so incredibly many stars and so much immense mass, you might naturally expect IC 1101 to be a brilliant hotbed of glorious stellar activity. But we must remember exactly how it grew so enormously large in the first place. Every single time it aggressively consumed another galaxy, it also consumed that unfortunate galaxy's entire precious gas supply. Interstellar gas is the fundamental fuel necessary for star formation. Without vast clouds of cold gas, new stars simply cannot be born into the universe. Over billions of years of relentless cannibalism, IC 1101 has systematically used up or violently expelled almost all of its available gas. The colossal mergers themselves were often violent enough to heat the surrounding gas to extreme, blistering temperatures, making it rapidly expand and escape the galaxy entirely. Or the gentle collisions compressed the gas so unbelievably quickly that it all formed into stars at once, in brief, incredibly intense bursts of brilliant activity. Either way, the ultimate end result is a majestic galaxy that has completely run out of raw material. What remains now is a quiet, ancient giant slowly fading into the eternal cosmic night. The trillions of stars that exist there right now will continue to gently shine for billions of years to come. But as they each eventually burn out and quietly die, there will be absolutely no new, bright generations to take their place in the dark. It brings a sense of melancholy wonder to our journey. IC 1101 is so much like an ancient legendary kingdom that has successfully conquered all of its surrounding neighbors, but sadly has no children left to carry on its grand legacy. It is staggeringly massive, incredibly powerful, and utterly magnificent to behold. But it is also steadily approaching the quiet end of its active, vibrant life. This tension between enormous scale and quiet decay fills the mind with awe. As we contemplate this fading kingdom, we are drawn inevitably toward its absolute center. For at the very heart of IC 1101 lies an entity even more incredible and perhaps more terrifying than the surrounding galaxy itself. Sitting in the deep, silent center of this cosmic giant is one of the absolute largest known supermassive black holes in the entire observable universe. As astronomers have discovered, every single large galaxy harbors a supermassive black hole at its core. Our own Milky Way gently circles one called Sagittarius A star, which contains roughly 4 million times the mass of our own Sun. The black hole resting at the center of the Andromeda Galaxy is considerably bigger, containing somewhere around 100 million to 200 million solar masses. But the silent monster at the center of IC 1101 exists in a completely different category of existence. Scientists meticulously estimate that this particular black hole contains somewhere between 40 billion and 100 billion times the mass of our Sun. I want you to simply rest with that number, to gently put that into our human perspective. This single, solitary black hole might possess 25,000 times more mass than the entire supermassive black hole at the center of our whole Milky Way galaxy. Let me try to help you truly understand just how unfathomably massive this actually is. If you could somehow manage to weigh the entire Earth, you would discover it has a mass of about 6 trillion kilograms. That sounds like an incredible amount until you quietly compare it to the Sun, which is about 330,000 times more massive than the Earth. Our Sun is a fairly ordinary, stable star, neither particularly large nor particularly small by typical stellar standards. Now, imagine multiplying the Sun's entire mass by 50 billion. That is roughly how much sheer mass is unimaginably packed into the supermassive black hole at IC 1101's silent center. All of that colossal mass is perfectly compressed into a region of space from which absolutely nothing can ever escape. The gravitational pull at the event horizon, which is the invisible boundary of the black hole, is so incredibly intense that even light itself, the fastest thing in the cosmos, cannot break free from its grasp. The physical size of a black hole's event horizon completely depends on its massive weight. For a supermassive black hole of 50 billion solar masses, the event horizon would possess a staggering radius of roughly 150 billion kilometers. That number might sound enormous to your ears, and it truly is. But remember always that this is a region containing 50 billion times the mass of our star, compressed into what is fundamentally a single point at the deep center. The event horizon is merely the quiet boundary beyond which any hope of escape becomes totally impossible. To place this into a perspective, we can almost grasp our entire solar system stretching all the way from the warm sun out to the frigid orbit of Neptune is about 9 billion kilometers across. The silent event horizon of IC 1101's black hole is roughly 16 times larger than our entire solar system. If you were to carefully place this black hole exactly where our sun is today, its dark event horizon would extend well beyond the distant orbit of Pluto, instantly engulfing absolutely everything we consider our cosmic home. What would it actually be like to travel near this monstrous black hole in the quiet void? The physics of such extreme, unimaginable environments is entirely bizarre and completely counterintuitive to our daily experiences. Time itself would essentially pass differently near the edge of the event horizon compared to observers far away in the safety of space. From the outside perspective, anything falling in would simply never seem to actually cross the boundary into the dark. It is a profound mystery that invites us to feel entirely safe in our lack of complete understanding. Inside the event horizon, all possible directions lead invariably toward the singularity hiding at the absolute center. Space and time themselves become so deeply warped and permanently twisted that the very concept of escaping becomes entirely meaningless to any observer. The singularity, an unimaginably tiny point of theoretically infinite density, would gently but inevitably tear apart absolutely anything that fell within its unfathomable grasp, slowly stretching it into incredibly long, thin strands through a fascinating, slightly terrifying process that physicists have playfully nicknamed spaghettification. It is a place where our current understanding of physics beautifully breaks down, inviting us to simply marvel at the profound limits of human knowledge. But here is something truly remarkable for us to softly ponder in the dark. Despite its enormous physical size and seemingly terrifying properties, the gargantuan black hole resting at IC 1101's deep center is currently relatively quiet. It is absolutely not actively devouring huge amounts of stellar matter right now. There is no brilliant, blinding accretion disk swirling violently around its dark edge. There is no incredibly powerful jet continuously shooting out into deep space at nearly the absolute speed of light. The black hole is simply there, quietly waiting in the silence, because it has already consumed the vast majority of the loose material that was easily within its gravitational reach. This peaceful, almost meditative quietness is actually intimately related to the exact same cosmic phenomenon that has firmly stopped IC 1101 from forming any beautiful new stars. Most of the available cold gas residing within the entire galaxy has already been entirely used up. and without vast, heavy clouds of gas gracefully falling toward the center, the sleeping black hole has very little left to eat. Occasionally, an unfortunate wandering star drifts just a little too close to the invisible boundary and gets gently torn apart, providing a brief, solitary meal for the giant. But these fleeting events are exceedingly rare in the grand timeline of the cosmos. The supermassive black hole, very much like the majestic ancient galaxy that securely hosts it, is a sleepy giant in profound repose, immensely powerful, but entirely dormant as it drifts through the ages. Yet there are still faint, echoing traces of the black hole's much more active, chaotic past. Astronomers have carefully detected a distinct radio source at IC 1101's deep center, precisely catalogued as PKS 508 plus 059. This quiet radio emission softly comes from relativistic jets, which are magnificent streams of tiny particles naturally accelerated to nearly the absolute speed of light and violently ejected from the immediate vicinity of the hungry black hole. These incredibly energetic jets are powerfully driven by the black hole's dizzying rotation and its immense, invisible magnetic fields, and they possess the astonishing ability to carve out absolutely enormous cavities in the surrounding hot gas. Breathtaking, ethereal images captured from advanced X-ray telescopes show these vast cavities clearly to our human eyes. They are unimaginably huge bubbles of very hot, very thin gas, blown forcefully outward by the sheer, staggering energy released near the waking black hole. Some of these delicate cosmic bubbles are millions of light years across, standing as a silent, ghostly testimony to chaotic periods in the ancient past, when the black hole was vastly more active than it is today. The total energy fundamentally required to successfully inflate these massive bubbles is absolutely staggering to comprehend, roughly equivalent to the total combined energy output of billions of shining stars burning steadily over millions of years. This intricate, delicate kind of feedback between supermassive black holes and their sprawling host galaxies is currently one of the absolute most active areas of quiet research in modern astrophysics. Scientists now deeply believe that supermassive black holes play a highly crucial role in delicately regulating galaxy growth and long-term cosmic evolution. When cold gas softly flows toward a galaxy's center, the sleeping black hole can suddenly release just enough immense energy to gently heat that gas and steadily push it outward, completely preventing it from cooling down and forming bright new stars. This process creates a fascinating kind of cosmic thermostat effect that beautifully helps determine the ultimate final size and the fundamental properties of the immense galaxies themselves. In IC 1101's specific, majestic case, this delicate feedback loop may be significantly responsible for the giant galaxy's current, sleepy, inactive state. The immense black hole has essentially helped to completely shut down star formation by gently heating the surrounding gas and denying the galaxy the fuel it needs. The giant galaxy and its intimately connected giant black hole have slowly reached a beautiful kind of permanent equilibrium, each one having deeply shaped the other over billions of years of shared, silent evolution. Black holes only ever grow by patiently consuming matter that accidentally falls into their dark embrace. When entire galaxies merge together, the supermassive black holes residing quietly at their centers eventually find each other in the dark and beautifully merge as well. Over the incredibly long course of IC 1101's deep history of galactic cannibalism, its central black hole has been gently fed again and again, meal after cosmic meal. Every single tiny galaxy that IC 1101 consumed softly added to the total mass of this ever-growing monster. Every single major merger brought in more raw, vital fuel for the black hole's once insatiable appetite. The unseen, intricate process by which two supermassive black holes eventually merge is endlessly fascinating and utterly violent on a scale we can barely imagine. When two massive galaxies initially collide, their central black holes absolutely do not immediately find each other in the swirling chaos. They remain separated by vast, dark distances and are thickly surrounded by billions of dancing stars. But as the quiet merger steadily progresses, subtle gravitational friction interacting with the surrounding stars causes the heavy black holes to slowly spiral downward toward the true center of the newly combined massive galaxy. Eventually, the two dancing black holes get close enough to form an intimate binary system, gracefully orbiting around each other in the cold dark. As they softly orbit, they continuously lose vital energy through the emission of gravitational waves, which are invisible, gentle ripples traveling through the very fabric of space-time itself. These profound, invisible waves carry tremendous energy away from the binary system, gradually causing the cosmic orbit to shrink tighter and tighter. The black holes spiral closer and closer, orbiting faster and faster, until, finally, they merge together in a completely catastrophic event that releases absolutely enormous amounts of hidden, quiet energy into the universe. When two supermassive black holes eventually merge, the gravitational waves they powerfully produce are among the absolute most energetic events in the entire cosmos. The final, spectacular merger releases more total energy than all the shining stars in a typical galaxy combined, though almost all of this profound energy is purely in the invisible form of gravitational waves rather than visible light. These subtle, powerful waves ripple outward at the exact speed of light, gently stretching and squeezing space itself as they silently pass through the absolute void. We human beings have only very recently developed the miraculous, delicate technology required to detect these gravitational waves passing through our own planet. The very first direct detection beautifully came in the year 2015, when the highly sensitive LIGO observatories precisely measured tiny waves, originally created from two smaller stellar mass black holes merging about 1 billion light-years away. Since that miraculous day of discovery, dozens of gravitational wave events have been quietly observed by our scientists, opening up an entirely new, breathtaking way of deeply studying the hidden, invisible universe. Future advanced gravitational wave detectors, such as the brilliantly planned LISA mission that will eventually fly peacefully in deep space, will actually be fully able to detect the distant mergers of truly supermassive black holes. When LISA finally launches, perhaps sometime in the 2030s, it might actually detect cosmic events incredibly similar to the ancient mergers that slowly built up IC 1101's massive central black hole. We will quite literally be able to peacefully listen to the universe as giant black holes silently collide and merge in the dark, gracefully adding another profound sense to our ever-growing astronomical toolkit. IC 1101's massive central black hole has highly likely experienced dozens of such dramatic mergers over its incredibly long ancient history. Each gentle merger added more raw mass and subtly altered the giant black hole's silent, dizzying spin. The repeated process of multiple mergers also deeply affected the surrounding galaxy, as the wildly swinging black holes violently flung countless stars outward through incredibly complex gravitational interactions. This violent, ancient scattering is very likely the main reason why IC 1101's galactic core is so physically large yet surprisingly faint to our watching telescopes. Repeated black hole mergers have essentially scattered trillions of stars completely away from the very center, intentionally creating a unique core profile that is highly unusual for elliptical galaxies of this colossal size. The core of IC 1101 is truly remarkable just for its sheer physical size alone. A detailed, careful study conducted in the year 2017, using beautiful images downloaded from the Hubble Space Telescope, carefully measured the galactic core and stunningly found that it stretches across nearly 14,000 light-years of space. That astronomical measurement essentially means that just the very central core of IC 1101, not even the whole galaxy itself, but just the innermost region alone, is substantially bigger than most entire dwarf galaxies floating freely in the universe. This central core alone firmly contains more individual stars than most entire galaxies possess. Now, I gently invite you to take a contemplative journey in your mind to help you truly appreciate the unimaginable scale of what we are quietly discussing together. Imagine if you could somehow manage to travel from one extreme end of IC 1101 all the way to the other edge. You would need to patiently cross somewhere between 4 and 6 million light-years of absolute space. Please remember that pure light travels at about 6 trillion miles per single year. Even moving at that completely incomprehensible speed, crossing IC 1101 would take millions upon millions of years to achieve. But let us try another, much more human comparison to firmly ground our cosmic awe. The Voyager 1 spacecraft, successfully launched by NASA in the year 1977, is currently the absolute fastest human-made object ever to permanently leave our solar system. It is quietly traveling through the interstellar dark at roughly 38,000 miles per hour relative to our warm sun. At that steady, impressive speed, Voyager 1 would require about 80,000 years just to softly reach the nearest star to our sun, Proxima Centauri, which is sitting only about 4 light-years away from our Earth. To completely cross the entire Milky Way galaxy at Voyager, one's current speed would painfully take about 2 billion years of travel. And to merely cross IC 1101, you would quietly need somewhere between 80 billion and 120 billion years. That unfathomable span of time is vastly more time than the entire universe has even existed. Even with our absolute fastest spacecraft, crossing this single ancient galaxy would be completely impossible. Here is yet another gentle way to quietly think about the staggering scale of this cosmic giant. If you could somehow magically shrink our Milky Way galaxy down to the manageable size of a dinner plate, roughly 10 inches across, then IC 1101 would comfortably be the immense size of a large swimming pool. Our entire home galaxy, with all of its hundreds of billions of shining stars and beautiful spiral arms, would be just a fragile dish floating aimlessly in a vast sea. Or consider this profound reality. The ancient light from IC 1101 has traveled for over 1 billion years, simply to reach our watching eyes. In all that long time, the light has been continuously streaming away from this giant galaxy in absolutely every direction. Every passing second, IC 1101 radiates enough light to easily travel about 186,000 miles. Over a span of 1 billion years, that light has peacefully traveled 1 billion light years, roughly 6 billion trillion miles of pure, silent space. It is only now arriving at our patiently waiting telescopes, delivering ancient photons that left their home galaxy when Earth was still resting in much earlier stages of complex life. The remarkable discovery and subsequent study of IC 1101 would never have been possible without tremendous advances in telescope technology. In the early days of astronomy, telescopes were profoundly limited by the physical size of their handcrafted lenses and heavy mirrors. Larger telescopes could gather more light and see fainter objects hiding in the dark. But there were strict limits to exactly how big you could physically make a telescope resting on the ground. The Earth's atmosphere also consistently posed a significant problem for these early astronomers. Our protective atmosphere is constantly moving and gently shimmering, which is precisely why distant stars appear to twinkle to our eyes. This poetic twinkling heavily blurs the delicate images that ground-based telescopes can capture, strictly limiting how clearly they can see ancient objects. For the vast majority of the 20th century, astronomers could only vaguely see that IC 1101 definitely existed and was very large, but they simply could not study its intricate structure through the shimmering veil of our sky. Everything profoundly changed for our understanding with the magnificent launch of the Hubble Space Telescope in the year 1990. Safely floating above the shimmering atmosphere, Hubble could capture images with incredible clarity. Over the quiet decades since its launch, Hubble has observed IC 1101 multiple times, beautifully revealing intricate details about its vast core, its surrounding halo of stars, and its complex relationship to other trapped galaxies within its massive cluster. More recently, dedicated astronomers have used a wide variety of other telescopes to study IC 1101 at entirely different wavelengths of light. Radio telescopes have beautifully detected the quiet emission from its central black hole. X-ray telescopes have carefully observed the incredibly hot gas that completely fills the immense cluster around it. Infrared telescopes have gently peered right through the cosmic dust to study the ancient stellar populations resting within the galaxy. Each new observation adds a vital piece to our profound understanding of this cosmic giant. Ground-based telescopes have also improved dramatically over the years. Modern observatories now use a fascinating technique called adaptive optics, which uses complex deformable mirrors and lasers to smoothly correct for atmospheric distortion in real time. The staggering result is clear images that gracefully approach the stunning quality of space-based observations, captured from telescopes much larger than anything we could possibly launch into orbit. The largest ground-based telescopes operating today have massive mirrors more than 30 feet across, gathering enormous amounts of ancient light and able to detect objects billions of times fainter than the unaided eye can possibly see. These beautiful instruments can gently observe IC 1101 in exquisite detail, measuring the motions of individual stars, analyzing the chemical composition of different parts of the galaxy, and tracking cosmic changes over deep time. Even more powerful telescopes are on the way. The James Webb Space Telescope, gracefully launched in late 2021, has already begun observing distant galaxies with unprecedented sensitivity in infrared light. The extremely large telescope, under careful construction in Chile, will have a mirror nearly 130 feet across when it finally sees first light in the late 2020s. There is also the deeply fascinating question of how exactly we measure the unfathomable distances to objects as incredibly far away as IC 1101. Distance is unequivocally one of the fundamental quantities in the science of astronomy, but it is also profoundly one of the hardest things to carefully measure. How do you accurately tell how far away something is when you simply cannot go there and stretch out a physical measuring tape in the dark? For relatively nearby stellar objects, astronomers beautifully use a geometric technique called parallax. As our Earth peacefully orbits the warm sun, our perspective on nearby stars changes very slightly. By carefully measuring exactly how much a star appears to shift against the static background of more distant stars over the slow course of a year, astronomers can calculate precisely how far away it is. This technique works exceedingly well for stars resting within a few thousand light years. But for vastly more distant objects, the delicate parallax shift is far too tiny to measure, even with our absolute most precise instruments. For these more distant objects floating in the deep dark, astronomers must gently rely on a cosmic distance ladder, a brilliant series of techniques that carefully build upon each other. One delicate rung of this cosmic ladder deeply involves a special beautiful type of star, carefully called a Cepheid variable. These fascinating stars naturally pulsate in brightness in a very regular, poetic pattern, and the exact period of their gentle pulsation is directly related to their intrinsic luminosity. By carefully measuring exactly how bright a Cepheid appears to us and how fast it steadily pulsates, astronomers can perfectly calculate precisely how far away it resides. Cepheids can be beautifully seen in galaxies tens of millions of light years away. But the silent giant IC 1101 is simply too distant even for this incredibly delicate technique. At over 1 billion light years away, individual Cepheid stars are far too faint for us to ever detect in the deep dark. For such truly extreme cosmic distances, astronomers are forced to gently rely on even brighter standard candles. One of the most critically important of these is a dramatic type of exploding star, elegantly called a type Io supernova. These massive explosions occur when a quiet white dwarf star slowly accumulates too much stellar matter from a companion and finally detonates in a majestic thermonuclear explosion. Because the exact conditions for this cosmic detonation are deeply similar from one supernova to another, they all beautifully reach roughly the exact same peak brightness. By carefully measuring exactly how bright a type Ia supernova gently appears, astronomers can accurately estimate just how far away its host galaxy is. Another profound technique delicately involves measuring the redshift of a distant galaxy's light. As the entire universe continuously expands, ancient light softly traveling from distant objects gets physically stretched to longer wavelengths. This beautiful stretching slowly shifts the light toward the red end of the visual spectrum, hence the poetic name redshift. The vastly more distant an object is, the more the entire universe has quietly expanded since its light was originally emitted, and the greater its visible redshift becomes. By carefully measuring the delicate redshift of the ancient light flowing from IC 1101, astronomers have scientifically determined that it is about 1.04 billion light years away from our Earth. This profound measurement, carefully combined with detailed observations of the giant galaxy's apparent size and gentle brightness, brilliantly allows them to calculate its massive physical properties, like its true diameter and staggering stellar mass. Each of these magnificent techniques fundamentally has small uncertainties, and measuring these cosmic distances is not a simple matter. Astronomers continuously refine their delicate methods, using brilliant new observations and an improved understanding of the underlying physics of the cosmos. The exact distance to IC 1101 might gracefully be revised as better data slowly becomes available to us, but the basic, awe-inspiring picture of an enormous galaxy sitting securely over 1 billion light years from Earth is remarkably well established in our minds. I also want to gently talk about what it truly means to observe something that is 1 billion light years away in the silent dark. When we look at IC 1101 through our magnificent instruments, we are absolutely not seeing the giant galaxy as it is today in the present moment. We are actually seeing it perfectly preserved as it was over 1 billion years ago, precisely when the ancient light we detect today first began its incredibly long journey toward our Earth. 1 billion years ago, our own beautiful planet Earth was a profoundly different place. Complex animal life had not yet even begun to evolve in the warm oceans. The planet was peacefully populated by simple, single-celled organisms, and perhaps some very early multicellular life, but absolutely nothing that would be instantly recognizable to us as an animal or a plant. The slowly shifting continents were in entirely different positions, gathered together in alien configurations that would be completely unrecognizable to our modern eyes. The atmosphere possessed a vastly different chemical composition, carrying different winds across the silent waters. It was an alien world by absolutely any scientific measure during all the immense time since that ancient era. Light from IC 1101 has been continuously, silently, traveling through the boundless space. It peacefully crossed the vast, chilling emptiness between the distant galaxies, occasionally passing through invisible clouds of intergalactic gas, or being gently bent slightly by the powerful gravity of intervening celestial objects. It traveled at the absolute fastest speed anything can possibly travel in the entire cosmos. Yet, the profound distance was so immense that it patiently took over 1 billion years to finally arrive. The IC 1101 we carefully observe in our telescopes today might actually be very different from the IC 1101 as it truly exists right now at this very moment. Over the staggering span of 1 billion years, so very much could have quietly changed. Trillions of stars that were brightly shining back then might have peacefully burned out by now. A few rare new stars might have mysteriously formed in the dark. The central supermassive black hole might have experienced entirely new chaotic feeding events or gone through extended periods of deep, dreamless dormancy. Smaller galaxies that were slowly falling toward IC 1101 a billion years ago might have been completely consumed and forgotten by now. We have absolutely no way of truly knowing what IC 1101 physically looks like at this exact present moment. The delicate information concerning its current state will not reach our world for another 1 billion years into the future. In a very real, poetic sense, we humans are the gentle archaeologists of the cosmos, forever studying the ancient past rather than the immediate present. Every single observation of a distant celestial object is a profound look back in deep time, a fleeting glimpse of exactly how things used to be rather than how they are now. This inescapable cosmic time delay is both a profound limitation and a beautiful opportunity for our minds. It naturally limits our fundamental ability to completely understand the current state of the universe, but it miraculously allows us to study cosmic history directly by simply looking at galaxies resting at different distances, and therefore at completely different points in the ancient past. Astronomers can carefully piece together exactly how giant galaxies have changed over cosmic time. We can gently see what certain galaxies looked like when the infant universe was very young, compare them to much more recent cosmic examples, and beautifully trace the slow evolution of immense structures over billions of years. IC 1101, peacefully seen as it was exactly 1 billion years ago, generously provides a perfect snapshot of a giant galaxy existing in a very particular, quiet stage of its long evolution. Other giant elliptical galaxies, some resting closer to us and some much farther away, wonderfully provide additional necessary snapshots. By carefully combining all of these disparate observations, Modern astronomers gracefully build up a comprehensive picture of exactly how such massive galaxies slowly form and elegantly change over deep time. Now, let me gently talk about something that endlessly fascinates me personally, something that touches upon our search for peace and understanding in the dark. The sheer numbers we have been quietly discussing together are so incredibly vast that they unfortunately tend to become abstract to our minds. 100 trillion stars, 4 to 6 million light years, 1 billion years of travel. These are numbers that our human brains naturally evolved to handle very poorly. We are biologically adapted for counting small groups of things, measuring short distances we can easily walk, and tracking time spans composed of fleeting seasons and human generations. Absolutely nothing in our earthly evolutionary history properly prepared us for the true cosmic scale. So, let me try to guide you through a few more gentle thought experiments to help make these staggering numbers feel much more real, much more intimate. Imagine for a moment that you deeply wanted to take a single photograph of every individual star resting in IC 1101. You possess a very fast, magical camera that can easily snap exactly one picture per second, and you absolutely never need to rest your eyes. How incredibly long would it slowly take to successfully photograph all 100 trillion stars? The stunning answer is over 3 million years of continuous clicking. If you had bravely started taking those pictures precisely when the very first humans evolved on Earth, you would still have millions of years of photography waiting ahead of you right now. Or gently consider this beautiful comparison. The tiny grains of sand resting peacefully on all the shores and beaches of Earth number perhaps in the low hundreds of trillions. The giant galaxy IC 1101 contains roughly as many brilliant stars as there are single grains of sand on every single beach on our entire planet combined. Each and every one of those countless stars is a massive nuclear furnace, steadily burning ancient hydrogen into heavy helium, generously releasing beautiful energy that streams outward into the void in absolutely every direction. Each one of them might possess orbiting planets. Each one possesses a deep story, a silent history, and an unknown future in the dark. Now, imagine simply trying to take a quiet walk completely across the vast expanse of IC 1101. The average human walking speed is a leisurely pace of about 3 miles per hour. At that gentle pace, walking 24 hours a day without ever stopping to sleep or breathe, it would impossibly take you about 50 trillion years to merely walk from one side of IC 1101 to the distant other. That length of time is over 3,000 times longer than the current, entire age of the known universe. You could peacefully walk for the entire history of absolutely everything that has ever happened since the spark of the Big Bang until this very moment. And you would have covered less than 1/13,000th of the staggering distance across this single, silent galaxy. Let us quietly think about the concept of communication across the dark. Pure light is unequivocally the absolute fastest thing in the entire universe, rapidly traveling at about 670 million miles per hour. A simple greeting message sent by a focused beam of light from one extreme side of IC 1101 would agonizingly take 4 to 6 million years just to softly reach the other side. If a curious civilization resting on one edge of IC 1101 bravely sent a hopeful message to a civilization living on the exact opposite edge, the receiving civilization would not even get the message for millions of years, and any polite reply would take many millions of years more to return. Basic communication across this single, immense galaxy would absurdly span geological timescales. These gentle thought experiments do not truly make the cosmic numbers completely graspable. Nothing can realistically do that. The human mind simply is not built for such staggering cosmic scales. But they can softly give us a beautiful sense of the vastness, a profound feeling of awe in our gut, even if not a true, complete understanding in our waking heads. Every time we try to hold these concepts, we stretch the very limits of human imagination. Let me now gently turn to a profound question that might quietly be lingering on your curious mind. If the ancient galaxy known as IC 1101 is truly so unimaginably enormous, are there gentle, intelligent beings living out their lives there in the dark? Could a majestic galaxy that firmly contains 100 trillion burning stars actually be a quiet home to intelligent life? This is precisely the kind of profound question that our current earthly science absolutely cannot answer directly right now. We possess absolutely no technological way of definitively detecting biological life in such incredibly distant galaxies. We human beings currently barely have the delicate technology required to carefully look for simple microbial life within our very own solar system, let alone across the silent gulfs to galaxies resting 1 billion light years away. But we can peacefully sit in the dark and think about what the staggering cosmic numbers quietly suggest to our searching minds. If biological life fundamentally requires stable planets to take root, and those planets must safely orbit warming stars, then a massive galaxy overflowing with vastly more stars should naturally possess vastly more potential homes for life to emerge. Our own familiar Milky Way galaxy might safely harbor somewhere between 100 billion and 400 billion silent planets. If even a vanishingly tiny fraction of those planets are biologically suitable for life, there could be millions of unseen worlds teeming with living things scattered throughout our home galaxy alone. Now, I gently invite you to softly scale that beautiful thought all the way up to the majestic proportions of IC 1101. With its unfathomable 100 trillion stars, this giant galaxy could easily possess hundreds of trillions of quiet, orbiting planets. Even if only one out of every single billion of those distant planets successfully developed some form of life, that staggering math would still mean hundreds of thousands of living, breathing worlds floating in that single cosmic structure. And even if only one out of every single trillion of those worlds successfully nurtured intelligent life, capable of building complex civilizations, that would still mean there are 100 advanced civilizations quietly existing in IC 1101. Of course, we must humbly remember that these specific numbers are deeply based on human assumptions that we absolutely cannot scientifically verify from our distant vantage point. We simply do not truly know exactly how common or remarkably rare life actually is in the grand universe. We do not know how frequently simple biological life successfully develops into searching, questioning intelligence. We do not even know for absolute certain that all life strictly requires rocky planets exactly like ours, or that it necessarily requires liquid water to flow, or that it must be fundamentally based on the element of carbon. The staggering diversity of physical conditions existing in the wide universe might be perfectly matched by an equally beautiful diversity of physical forms that life itself can mysteriously take. What we can confidently say with gentle certainty is that IC 1101 wonderfully offers an absolutely enormous cosmic canvas for whatever mysterious physical processes might naturally lead to life. A magnificent galaxy of that monumental size has been continuously producing burning stars for billions upon billions of years. The critically vital heavy elements, like the carbon that forms life, the oxygen that beings might breathe, and the iron that might run through their veins, have been faithfully manufactured deep in ancient stellar cores and violently scattered through the dark by dying supernovas countless times. Whatever the true, hidden cosmic recipe for life might actually be, IC 1101 has possessed vast, unimaginable resources and absolutely enormous stretches of deep time to patiently cook it up. And if intelligent life does indeed quietly exist somewhere deep within the vastness of IC 1101, what might those gentle beings think when they look up at their own mysterious night sky? Their upward view would be profoundly different from our own earthly perspective, where we simply see a relatively sparse, quiet field of individual stars softly divided by the ethereal band of the Milky Way. Those distant observers would see brilliant stars absolutely everywhere, crowding their vision in every single conceivable direction. The physical density of ancient stars residing in a massive elliptical galaxy like IC 1101 is vastly higher than the density found in the flat disk of a spiral galaxy like ours. If their home planet rested near the deep center of IC 1101, their local night sky would be completely ablaze with constant, overwhelming light. The ancient stars would crowd so incredibly closely together that there might not be any true darkness at all on their world. The combined intense glow of billions upon billions of nearby neighboring stars would beautifully fill their sky with a permanent, perpetual twilight. Traditional cosmic navigation simply by observing the stars would be utterly impossible for them, because there would be vastly too many stars to ever properly distinguish one from another. Further out from the dense center, the celestial conditions would be slightly more like what we peacefully experience on Earth, but still deeply different. Absolutely no curving spiral arms would romantically trace beautiful patterns across their dark sky. Instead, the countless stars would be smoothly distributed in a much more spherical, perfectly uniform pattern, completely surrounding any curious observer in a glorious, unbroken shell of ancient stellar light. Would such intelligent beings gently know about the chaotic, violent history of their own massive galaxy? Would they have successfully discovered that their majestic home was essentially built from the broken remains of dozens of much smaller galaxies, completely consumed over billions of years of silent cosmic violence? We simply cannot know the quiet answers to these mysteries, but it is profoundly fascinating to think that somewhere in IC 1101, intelligent beings might be quietly asking the exact same beautiful questions about the nature of the universe that we ask right here on Earth. They might even have successfully detected our own tiny Milky Way galaxy, though from their unimaginably distant perspective, our beloved home would be just another completely unremarkable spiral galaxy, lost among billions of others in the dark. Now, I gently invite you to explore the invisible environment that perfectly surrounds IC 1101, because absolutely no galaxy exists in complete isolation. IC 1101 majestically sits at the very heart of the Able 2029 galaxy cluster, and understanding this massive cluster helps us understand why IC 1101 became so staggeringly enormous. Galaxy clusters are some of the absolute largest gravitationally bound physical structures in the known universe. They can safely contain hundreds or even many thousands of individual ancient galaxies, all peacefully orbiting around a shared common center of massive gravity. The vast space resting between the individual galaxies in a cluster is absolutely not perfectly empty. It is completely filled with an extremely hot gas, heated to unimaginable temperatures of tens of millions of degrees by the immense gravitational energy released as the cluster slowly formed over eons. Able 2029 is what astronomers call a relaxed cluster, meaning it has successfully settled into a fairly stable, peaceful configuration over billions of years. The countless galaxies residing within it have had ample deep time to softly sort themselves out, with the absolute most massive one slowly sinking toward the very center due to a fascinating physical process called dynamical friction, as incredibly massive cosmic objects slowly move through a vast sea of much smaller celestial objects. They naturally experience a gravitational drag that gently slows them down and inevitably causes them to gracefully spiral inward. IC 1101 majestically sits exactly at the very bottom of this immense gravitational well, resting peacefully at the absolute densest part of the cluster where ancient galaxies are packed most tightly together. This dominant location is absolutely not a simple cosmic coincidence. IC 1101 grew to be so staggeringly large precisely because it was located in this highly privileged position. The exact same physical process that brought IC 1101 to the very center also faithfully brought it a constant, endless supply of helpless victims to continuously consume in the dark. Let us quietly delve deeper into the invisible sea that bathes this colossal structure. The profoundly hot gas that completely fills the immense galaxy cluster also plays a critical, continuous role in IC 1101's long evolution. This invisible gas, beautifully called the intra-cluster medium, is incredibly sparse by our normal earthly standards. If you could somehow magically scoop up a single cubic meter of it in your hands, you would quietly find only a few solitary atoms floating within. But because there is simply so incredibly much of it smoothly spread over millions of light years of deep space, it naturally adds up to an absolutely enormous amount of mass. This ancient gas is so unbelievably hot that it continuously emits powerful X-rays, which is exactly how our modern astronomers manage to detect it. Brilliant X-ray telescopes, like NASA's Chandra Observatory, have carefully mapped the delicate distribution of this intensely hot gas in Abel 2029, beautifully revealing that it is heavily concentrated around IC 1101, exactly at the cluster's deep center. The glowing gas forms a kind of ethereal atmosphere completely around the giant galaxy, a very thin haze of superhot particles, peacefully extending millions of light years out into the dark space. As we gently float through this super-hot cosmic haze, contemplating the invisible forces that shape our universe, I want to take a brief, quiet moment to warmly welcome you. I am Theodore, the researcher, your dedicated companion on this peaceful journey through the deep cosmic mysteries. I have gently noticed that 71% of the beautiful souls who regularly watch these videos have not yet subscribed to our quiet channel. If you are finding a sense of inner peace and intellectual safety in our shared explorations, please consider subscribing. It helps us tremendously and allows us to continue building this wonderful community of curious cosmic explorers together. Now, let us peacefully return our gaze to the ancient, hot atmosphere perfectly surrounding our sleeping giant. The sheer presence of this exceptionally hot gas has profound, inescapable implications for IC 1101's distant future. Extremely hot gas can naturally cool down over immense spans of time, slowly radiating away its internal energy as invisible X-rays. When it eventually cools enough, it can softly fall into the central galaxy and potentially fuel beautiful new bursts of star formation. In some other galaxy clusters scattered throughout the void, Astronomers have actually observed enormous, gentle flows of cooling gas representing hundreds of solar masses worth of material per single year, continuously streaming down into the central galaxy. But in IC 1101's specific, majestic case, something invisible seems to be firmly preventing this cooling flow from ever igniting a bright new burst of star formation. The leading scientific theory is that the sleeping supermassive black hole resting at IC 1101 center is entirely responsible for this quiet suppression. When cold gas gracefully falls toward the dark black hole, some of it gets violently heated up and powerfully blown back out into the surrounding cluster. This fascinating physical process creates a delicate feedback loop where the giant black hole actively regulates the cluster's gas supply, completely preventing too much from ever accumulating and forming new stars. We can actually see the physical evidence of this invisible feedback in careful observations of IC 1101 and its surrounding environment. There are massive cavities resting in the hot gas perfectly around the galaxy, enormous bubbles that have been forcefully blown by ancient jets shooting from the central black hole. These silent cavities are millions of light years across, standing as enormous voids carved out of the intra-cluster medium by the immense energy output of the black hole over deep time. This delicate feedback mechanism is thought to be incredibly important for deeply understanding why absolutely massive elliptical galaxies like IC 1101 are completely failing to form new stars today. Without the central black hole carefully regulating the incoming gas supply, massive cooling flows would definitely deliver enough raw material to safely trigger substantial star formation in the dark. But the silent black hole effectively acts exactly like a cosmic thermostat, gently heating up the surrounding gas whenever too much starts to cool, peacefully keeping the entire giant galaxy in a kind of permanent, stable energy balance. Let us now gracefully travel backward through deep time, carefully exploring a gentle timeline of IC 1101's incredible history as best as our scientists can realistically reconstruct it from modern observations and theoretical models. This majestic timeline seamlessly spans billions upon billions of years and involves physical processes that are profoundly difficult for our human minds to imagine. But deeply understanding it helps us deeply appreciate exactly how this cosmic giant came to silently be. The long story peacefully begins about 13 billion years ago, not very long after the magnificent Big Bang itself. The entire universe at that ancient time was fundamentally different from what we can clearly see today. There were absolutely no magnificent galaxies yet, just incredibly vast dark clouds of simple hydrogen and helium gas, perfectly left over from the very first few minutes of cosmic history. These ancient clouds were naturally not perfectly uniform across the silent void. Some isolated regions were slightly denser than others, and gentle gravity slowly began to pull these tiny, denser regions together in the dark. Over the very first few 100 million years, these slightly denser regions peacefully collapsed to form the very first burning stars and the very first primitive galaxies. These early galaxies were incredibly small, highly irregular collections of ancient stars looking absolutely nothing like the grand sweeping spirals and smooth ellipticals we beautifully see today. They quietly formed in the absolute densest parts of the invisible cosmic web, the vast network of dark filaments and nodes that perfectly define the large-scale physical structure of our universe. The specific region of dark space that would eventually become the massive Abel 2029 cluster was exactly one of these dense, busy regions. Many small, fragile galaxies miraculously formed there, and they immediately began violently interacting with each other in the dark. Mergers happened incredibly frequently in the ancient early universe, simply because galaxies were physically much closer together, and the entire cosmic web was vastly more physically compact than it is today. One of those early, fragile galaxies, or much more likely a messy merger product of several early galaxies, was the direct ancient ancestor of ICE 1101. We honestly do not know exactly what this ancient proto-galaxy looked like to the eye, but it was probably a chaotic collection of a few billion stars, maybe measuring 100,000 light years across, with a slowly growing dark black hole safely resting at its center. Over the next several billion years, this ancient proto-galaxy steadily experienced merger after violent merger in the silence of space. Each time a smaller, unsuspecting galaxy wandered too close in the dark, relentless gravity perfectly captured it and eventually absorbed its entire essence. Each ancient merger added trillions of stars and vast oceans of gas, and each merger faithfully fed the central black hole. The growing galaxy became larger and larger, and its privileged position resting at the very center of a dense cosmic region ensured a steady, endless supply of helpless victims. By about 10 billion years ago, the voracious ancestor of IC 1101 had probably already become a truly giant elliptical galaxy, having faithfully experienced dozens of major, violent mergers. It would have easily been one of the absolute largest galaxies in its entire part of the young universe, even then, though certainly not yet as impossibly massive as it is today. The next several billion years peacefully saw continued steady growth, though at a progressively slower cosmic pace. The absolute most intense period of active galaxy formation was slowly winding down completely across the entire universe. Star formation rates were steadily declining as all galaxies simply used up their precious gas supplies. Mergers became much less frequent as the relentless, invisible expansion of the universe slowly carried distant galaxies farther and farther apart into the dark. But IC 1101 was securely locked in a very special location. The surrounding massive cluster acted as a gentle shield and a steady provider, perfectly ensuring that the giant continued to grow while others starved. The Abel 2029 cluster had slowly grown and beautifully matured, and IC 1101 sat patiently at its dark heart. Galaxies continued to fall gracefully toward the cluster center, drawn irrevocably by the enormous combined gravity of absolutely all the matter resting there. And when they finally reached the quiet center, they inevitably encountered IC 1101. During this ancient extended period, IC 1101 probably experienced another 20 or 30 major mergers, beautifully interwoven with countless minor ones. Each gentle merger added substantially to its total mass. Each collision stirred up its trillions of stars in a silent cosmic dance. Each merger fed its already enormous, waiting black hole. By about 5 billion years ago, IC 1101 had slowly grown to something very close to its current magnificent size. It securely contained tens of trillions of stars perfectly spread across millions of light years of cold space. Its central black hole had steadily grown to tens of billions of solar masses, and it had essentially run entirely out of easy prey in the dark. The remaining galaxies that still populated the massive cluster were either entirely too far from the dense center to be easily captured, or they were locked securely in stable, eternal orbits that would take many more billions of years to slowly decay. IC 1101 had consumed almost all of what it could possibly consume in its immediate cosmic neighborhood. Its chaotic days of rapid, violent growth were finally over. What remains today for us to observe is a beautifully dying giant, still utterly enormous, still fundamentally magnificent, but absolutely no longer growing. Its countless stars are old and tired. Its primordial gas is completely depleted. Its massive black hole is relatively quiet, only occasionally flaring up in the silence when a small bit of gas wanders just a little too close, but mostly it remains entirely dormant. IC1101 has slowly reached something resembling a permanent steady state, gracefully fading into the endless night as its ancient stars burn out one by one. This profound history is absolutely not unique to IC1101. Many giant elliptical galaxies resting at the very centers of massive clusters possess beautifully similar stories of ancient growth and quiet decay, but IC1101 represents a truly extreme case. An ancient galaxy that was perfectly situated in exactly the right place, at precisely the right time, to steadily grow to truly exceptional proportions over billions of years. It is perhaps not the absolutely only giant in the entire universe, but it remains one of the very largest we have ever successfully found, hiding in the deep dark. As we peacefully reflect on this journey, I want to gently guide our thoughts toward exactly what IC1101 means for our profound understanding of the universe and our quiet place within it. The majestic universe is deeply hierarchical in its fundamental nature. Small things patiently combine together over eons to make vastly larger things. Invisible atoms slowly form burning stars. Shining stars gracefully form massive galaxies. Sweeping galaxies carefully form enormous clusters. Bound clusters patiently form incomprehensible superclusters. This beautiful hierarchical structure is unequivocally one of the defining features of the cosmos we intimately inhabit, a direct, beautiful consequence of exactly how gravity quietly operates over immense stretches of cosmic time. IC1101 beautifully represents the absolute upper end of this vast hierarchy for individual, solitary galaxies. There may indeed be physically larger structures stretching across the universe, such as vast cosmic walls and incredibly long filaments of galaxies peacefully stretching for hundreds of millions of light years. But when it deeply comes to single, distinct objects bound intimately together by their own internal gravity, giant elliptical galaxies exactly like IC1101 are essentially as big as it ever gets in the cosmos. Deeply understanding the absolute limits of these cosmic structures beautifully teaches us about the underlying hidden physics of the entire universe. The simple fact that IC1101 is about 4 to 6 million light years across, rather than a completely impossible 1 billion light years across, tells our curious scientists something profound about exactly how the gentle pull of gravity, the mysterious presence of dark matter, and the relentless cosmic expansion all perfectly balance against each other in the dark. If absolutely any of these fundamental factors were even slightly different from what they are, the absolute largest galaxies might be vastly larger or incredibly smaller than what we actually observe in the night sky. In a very deep, poetic sense, IC1101 is a silent message from the universe about its very own nature. By carefully studying this gentle giant, we patiently learn about the absolute rules that seamlessly govern absolutely everything, from the smallest invisible atoms to the largest, most majestic structures. We peacefully learn about exactly how deep time, silent gravity, and pure energy have intricately shaped the entire cosmos over billions of years of history. But our quiet journey through the nature of reality is far from over, for the larger universe is continuously changing in profound ways that will eventually affect every single galaxy, including this enormous sleeping giant. The dark space itself is actively expanding, and not just simply expanding, but actually accelerating in its silent expansion. This mysterious acceleration is powerfully driven by something scientists carefully call dark energy, a profoundly mysterious cosmic force that makes up about 68% of the total energy in the entire universe, but whose actual, fundamental nature we absolutely do not understand at all. Let me gently explain the profound mystery of dark energy a little bit more, because it is unequivocally one of the absolute most fascinating and deeply puzzling discoveries in all of modern science. For the vast majority of the 20th century, brilliant astronomers quite naturally assumed that the expansion of the universe was slowly, peacefully slowing down. This made perfect intuitive sense to the human mind. Absolutely everything in the entire universe is constantly pulling on absolutely everything else through the gentle, invisible force of gravity. You would quite naturally expect all of that immense gravitational attraction to firmly act exactly like a cosmic brake, gradually and peacefully slowing the initial expansion that originally began with the magnificent Big Bang. However, in the remarkable year of 1998, two entirely independent teams of dedicated astronomers made an absolutely shocking, paradigm-shifting discovery in the dark. They were carefully measuring the precise expansion rate of the vast universe by patiently observing distant supernovas, brilliantly using them as reliable standard candles to accurately calculate immense cosmic distances. What they beautifully found was completely unexpected and profoundly challenged our understanding of reality. The universe was absolutely not slowing down. It was silently, powerfully speeding up. Distant ancient galaxies were actually moving away from us vastly faster than the closer ones, and the overall rate of cosmic expansion was undeniably accelerating over deep time. This revelation was so entirely unexpected that the brilliant astronomers initially thought they had simply made a mathematical error in their careful calculations. But as vastly more data peacefully came in from more distant supernovas and from entirely other types of cosmic observations, the astonishing result held up perfectly. Something invisible was powerfully pushing the entire universe apart, directly counteracting the gentle pull of gravity and beautifully causing space itself to silently expand at an ever-increasing rate. Scientists carefully named this profoundly mysterious force dark energy, though the poetic name tells us very little about what it actually, physically is. We do know that dark energy makes up roughly 68% of all the total energy in the entire universe. We know with certainty that it quietly acts as a kind of silent anti-gravity, gently pushing space apart rather than pulling it closely together. We know that its profound cosmic effects become increasingly more important over immense time as the universe silently expands and ordinary, visible matter becomes vastly more spread out in the deep dark. But we honestly do not know what dark energy is truly made of, exactly where it mysteriously comes from, or fundamentally why it possesses the specific, delicate strength that it does. It might simply be an inherent property of empty space itself, something beautifully called the cosmological constant that Albert Einstein once famously proposed and then deeply regretted, calling it his biggest blunder. It might be an entirely new kind of invisible energy field that quietly pervades the entire universe. It might even be a profound sign that our human understanding of gravity itself is fundamentally incomplete and desperately needs to be completely revised. What we do gracefully know is that dark energy is entirely reshaping the ultimate future of the entire cosmos. As dark space expands faster and faster in the silence, distant celestial objects steadily recede from us at ever-increasing cosmic speeds. There is a strict physical limit to exactly how fast light can travel, but there is absolutely no limit to how far space itself can silently expand. Eventually, over unimaginable eons, distant objects will be carried completely away from us by the relentless expansion of space, vastly faster than their ancient light can possibly travel toward us. When that silent, lonely moment finally happens, they will permanently vanish behind an invisible cosmic horizon, forever beyond our human reach and our telescope's gaze. For the sleeping giant IC 1101, this inexorable process means that its ancient days of active growth through galactic cannibalism are strictly numbered. Eventually, there will simply be absolutely no more galaxies left in its reach for it to peacefully consume. It will inevitably become entirely isolated, a deeply lonely giant floating silently in an ever-emptying dark universe, quietly watching as one by one the other distant galaxies simply fade from view. Let me gently paint a vastly more detailed, contemplative picture of exactly what this distant, silent future truly looks like for our universe. Please remember that IC 1101 peacefully sits deep in the Obel 029 galaxy cluster, perfectly surrounded by hundreds of other ancient galaxies. These neighboring galaxies are intimately bound together by the gentle strength of gravity, smoothly orbiting around their shared, common center of immense mass. For right now, in this brief cosmic moment, gravity is still strong enough to successfully hold the local cluster completely together against the relentless, tearing expansion of space. But in about 100 billion years into the deep future, the cosmic expansion will have silently accelerated to the exact point where all galaxies resting outside the local supercluster will simply start to disappear completely over the distant cosmic horizon. From IC 1101's silent, ancient perspective, the vast night sky will slowly, relentlessly start to empty out. One by one, distant galaxy clusters will peacefully fade from view, their ancient light simply no longer able to reach across the rapidly expanding dark void. The entire observable universe, which currently contains about 2 trillion brilliant galaxies, will silently shrink and shrink until almost nothing remains. Within the Abel 2029 cluster itself, things will remain peacefully different for a while longer in the dark. The ancient galaxies resting there are currently close enough and bound tightly enough that they will softly stay together, even as the larger, wider universe empties out entirely. Over the next several billion years, these captive galaxies will continue to gently interact, gracefully merge, and beautifully evolve. IC 1101 might still manage to softly consume a few more helpless victims, growing slightly larger even as the rest of the entire universe quietly slips completely away. But eventually, even the galaxies locked securely within the cluster will inevitably merge together in the silence. The exact same physical processes that painstakingly built IC 1101 will peacefully continue drawing the remaining galaxies toward the dense center, where they will be gently absorbed into an even larger, utterly massive combined structure. In the very long run, perhaps in several 100 billion years, absolutely all the galaxies residing in the Abel 2029 cluster might perfectly merge into a single, enormous galaxy, even vastly larger than IC 1101 is today. By that incredibly distant time, however, the vast universe beyond the cluster will be essentially completely empty. Absolutely no light from distant cosmic objects will be reaching the sleeping cluster anymore. The night sky, if any gentle observers still existed to look up, would gracefully show only the quiet stars of the local, merged galaxy, perfectly set against a vast backdrop of absolute, unbroken blackness. The rest of the entire cosmos would have silently slipped permanently beyond the invisible horizon, entirely unreachable and forever unknowable. This profound, quiet isolation is exactly what awaits IC 1101 and absolutely every other cosmic structure floating in the universe, entirely cut off from absolutely everything else by the relentless, silent expansion of dark space. Each massive island of ancient matter will be entirely alone with itself as the quiet eons simply roll by into infinity. As we contemplate this lonely, beautiful truth, we are invited to feel a deep sense of wonder for the present moment. We exist in a cosmic era where the night sky is still filled with light, where the universe is still visibly interconnected, and where we can still reach out with our minds to touch the vastness before it fades into silence. This quiet realization brings a profound sense of peace and deep gratitude for the fleeting, beautiful mystery of our shared existence in this vast, ancient cosmos. But even this grand isolation is absolutely not the final, quiet fate of IC 1101 in the deep dark. What eventually happens to an enormous galaxy in a silent universe that is slowly, peacefully winding down toward its ultimate heat, death? The melancholy answer is as magnificent as it is deeply beautiful to contemplate. Over the next 100 trillion years, the countless stars in IC 1101 will slowly, gracefully burn out in the dark. The massive blue stars, which once blazed with brilliant fury, went long ago, either exploding as spectacular supernovas or collapsing quietly into silent black holes. The middle-sized stars, much like our own warm sun, will slowly puff up into beautiful red giants, gently shedding their outer layers as colorful planetary nebulas, and then quietly fade away forever as cold white dwarfs. Even the absolute smallest, longest-lived stars in the cosmos, the dim red dwarfs that burn their nuclear fuel so incredibly slowly that they can shine for trillions of years, will eventually exhaust their precious hydrogen and quietly go completely dark. Before we descend further into this quiet era of fading starlight, let us pause for a gentle moment of connection. I am Theodore, the researcher, your companion through this vast cosmic silence. Did you know that 71% of the curious souls who join us on these deep journeys have not yet subscribed to our channel? If these meditative, scientific explorations bring a sense of calm and wonder to your day, please consider subscribing to the channel. Your simple subscription helps us immensely to keep researching and sharing these cosmic mysteries, guiding our collective minds deeper into the infinite night. Now, let us return our thoughts to the slow, beautiful decay of the stellar era. Let us walk together through this deep stellar death in detail, because the unimaginable timescales involved are truly mind-boggling to our earthly senses. The most massive stars in IC 1101, those glorious blue giants, live fast and die incredibly young. They burn through their life-giving fuel in just a few million years before exploding as supernovas. Any blue giants that IC 1101 once proudly possessed burned out billions of years ago in the dark. The galaxy today is heavily dominated by much older, smaller, and longer-lived stars. Stars that are most similar to our own sun typically have natural lifetimes of about 10 billion years. Our sun is currently roughly halfway through its active life, with about 5 billion years left before it swells into a red giant and eventually becomes a quiet white dwarf. In IC 1101, untold numbers of sun-like stars have already completed this slow process, leaving behind cold, white dwarf remnants. Others are still shining bravely, but over the next several billion years, they too will inevitably burn out. But the absolute most numerous stars in any galaxy are the red dwarfs, those tiny stars with just a fraction of our sun's mass. Red dwarfs burn their fuel so slowly that they can continuously shine for trillions of years. A tiny red dwarf born at the same time as our sun will still be shining, long after our sun has become a cold, dark, white dwarf. In IC 1101, with its majestic 100 trillion stars, there are untold numbers of these red dwarfs. These tiny dim stars will be the absolute last to go out in the universe. For trillions of years after the larger, brighter stars have quietly died, the red dwarfs will continue to burn, providing the only faint light in an otherwise darkening galaxy. But even red dwarfs have their physical limits. The absolute smallest red dwarfs, with perhaps only 8% of our sun's mass, can burn for up to 10 trillion years. That is about 700 times the current age of our universe. But eventually, even they will exhaust their hydrogen fuel and quietly fade into the eternal darkness. Scientists estimate that active star formation in our universe will effectively cease completely in about 100 trillion years. By that incredibly distant time, the gas and dust needed to make new stars will have been entirely used up or dispersed far too thinly to ever collapse under gravity. No new stars will ever be born to replace the ones that have died. The glorious era of starlight will be permanently over. One by one, the 100 trillion stars of IC 1101 will slowly wink out. The galaxy will grow dimmer and dimmer over time scales that make the current age of our universe seem like the briefest blink of an eye. Where once there was a magnificent blaze of stellar light, there will eventually be absolutely nothing but the cold, dark remnants of dead stars, white dwarfs, neutron stars, and black holes drifting endlessly through an ever-expanding void. The universe at this stage will be a dark place, but it will absolutely not be a completely empty one. All those stellar remnants, all those white dwarfs, neutron stars, and black holes will still physically exist. They will continue to orbit through the merged remnant of what was once IC 1101 and its cluster companions. The galaxy will be a quiet ghost of its former self, populated exclusively by the cold corpses of stars rather than by living, burning suns. But even this is absolutely not the ultimate end of our journey. Over even longer time scales, measured in years with so many zeros that writing them out would fill entire pages, even these stellar corpses will gradually decay. White dwarfs will slowly cool until they become black dwarfs, cold objects that no longer emit absolutely any light or heat. This cooling process takes an almost inconceivable amount of time. A white dwarf cools to near absolute zero only after about 10 to the 15th power years, or about 1,000,000 billion years. That is roughly 100,000 times longer than the current age of our universe. And the black holes, including that enormous monster at the center of IC 1101, will slowly evaporate through a process called Hawking radiation. Stephen Hawking discovered that black holes are not truly black. They slowly leak particles and radiation over immense time spans, gradually shrinking as they do so. This happens because of quantum mechanical effects near the event horizon. In the strange world of quantum physics, particle pairs are constantly popping into existence and then annihilating each other. Near a black hole's event horizon, one member of such a pair can fall into the black hole while the other escapes into space. Over time, this process drains energy from the black hole, causing it to shrink. The rate of Hawking radiation is incredibly slow for large black holes. A black hole with the mass of our Sun would take about 10 to the 67th power years to evaporate. That is a 1 followed by 67 zeros. But the supermassive black hole at the center of IC 1101 is billions of times more massive than the Sun. And the time for it to evaporate is correspondingly longer. A black hole containing 50 billion solar masses would take something like 10 to the 100th power years to evaporate. Or maybe even longer. That is a Google years. A 1 followed by 100 zeros. It is a span of time so vast that everything we have discussed so far is not even a rounding error by comparison. When that final silent evaporation finally happens, there will be absolutely nothing left of IC 1101 at all. No stars, no black holes, no remnants of any kind, just the elementary particles and weak radiation spreading out through an ever-expanding, ever-darkening universe. This vision of the deep future might seem incredibly bleak to some, but I find something strangely beautiful and comforting about it. IC 1101 exists right now in this brief, brilliant moment of cosmic history when stars still shine and galaxies still glow. It has existed for billions of years and will continue to exist for billions more in the grand sweep of cosmic time. We are lucky enough to exist during this flowering. We are lucky enough to have evolved intelligence, built telescopes, and pointed them at the sky. We are lucky enough to have discovered IC 1101 and to understand, at least in part, what it is and how it came to be. In all the vast history of the universe, stretching from the Big Bang to the final heat death, this moment right now is special. It is the moment when the universe has developed the beautiful ability to look at itself and wonder. And what we see when we look at IC 1101 is the grandest scale on which the universe has assembled matter into organized structures. We see billions of years of cosmic history written in stars. We see a monster, yes, but also a monument to the forces that shape our universe and to the processes that have been building complexity ever since the first atoms formed in the dark. Let us now gently bring our wandering minds back a little closer to our own cosmic home, for the Milky Way itself is absolutely not immune to the immense, patient forces that slowly shaped the grand monument of IC 1101. We too, in our quiet corner of the deep night, are active participants in this beautiful, ancient cosmic dance of galactic interaction and eventual merger. Even as you sit in quiet contemplation, breathing in the peaceful stillness of the present moment, our entire galaxy is in the slow, silent process of gradually consuming several much smaller neighbor galaxies. The tiny Canis Major dwarf galaxy is currently being gently ripped apart by our immense gravity. Its ancient stars slowly absorbed into the grand disk of the Milky Way. The Sagittarius dwarf galaxy is likewise being stretched and distorted into long, ghostly stellar ribbons by our powerful, invisible gravitational pull. Streams of stars from past victims can actually be traced by our modern instruments across the dark sky, serving as quiet, beautiful reminders of separate galaxies that once existed in their own right before being welcomed into our massive home and in the deep, distant future. An even more breathtaking and dramatic event patiently awaits our quiet cosmic neighborhood. The Andromeda Galaxy, our nearest large cosmic neighbor, is currently heading directly toward us through the deep dark. For a very long time, dedicated scientists have firmly believed that in about 4 to 5 billion years, the Milky Way and Andromeda would inevitably collide, eventually merging over eons into a single, much larger elliptical galaxy, which astronomers have affectionately nicknamed Milkomeda. However, recent scientific research has introduced a beautiful, fascinating layer of uncertainty into this grand prediction. New, highly precise studies utilizing rich data collected from the European Space Agency's Gaia spacecraft and the Hubble Space Telescope suggest that this colossal collision might not be as completely certain as we once comfortably assumed. When astronomers carefully account for the complex gravitational influence of other nearby galaxies, such as the massive Large Magellanic Cloud and the smaller Triangulum Galaxy, they discover that the delicate path of our future is far more intricate. Some advanced computer simulations now suggest only about a 50% chance of a complete major merger happening within the next 10 billion years. But whether this grand collision happens in 4 billion years, 10 billion years, or perhaps not at all, the sheer physical process itself beautifully illustrates the exact same fundamental forces that painstakingly created the staggering giant IC 1101. Galaxies interact, they slowly dance around one another, they merge, and they consume each other in a beautiful, silent competition that defines the very evolution of our universe. Even our own quiet, peaceful corner of the cosmos actively participates in this grand, ancient game. If the spectacular merger between our home and Andromeda does eventually happen, the physical results will be absolutely spectacular to behold, at least on immense cosmic timescales. Yet, the collision itself would absolutely not be violent or destructive in the way our human minds typically imagine a collision on Earth. The individual stars within both giant galaxies are situated so incredibly far apart from one another that the physical chances of any two stars actually colliding head-on are essentially completely zero. Instead, the complex gravitational effects would be beautifully dramatic and sweeping. The familiar spiral structures of both galaxies would be completely, permanently destroyed in the slow, silent interaction. Immense, ancient gas clouds would be gently compressed by passing shock waves, instantly triggering enormous, brilliant bursts of star formation across the night sky. The two supermassive black holes currently resting quietly at the centers of each galaxy would eventually find each other in the new, chaotic center and beautifully merge, releasing powerful gravitational waves that would ripple silently across the entire universe. Over immense spans of deep time, the chaotic gravitational tides would slowly settle down into a peaceful, stable equilibrium. What was once our familiar Milky Way and what was once Andromeda would gracefully blend together into a single, massive, and smooth elliptical galaxy. Very much like a smaller version of IC 1101. Future astronomers, if any intelligent observers still exist on some distant planet to look up at the night sky, might look back at ancient, preserved records and marvel with deep wonder that their smooth, featureless, and quiet home galaxy was once two separate, beautiful spiral structures gracefully dancing through the empty void of space. By that incredibly distant time, of course, our beloved planet Earth will be long gone, having completed its quiet story in the cosmos. Our warm, stable sun is scientifically expected to expand into a massive red giant in about 5 billion years, swelling to a colossal size that will inevitably engulf our fragile planet entirely. whether our human descendants will somehow survive until then, whether we will have successfully spread to other distant star systems, or whether intelligence of any kind will still persist in the wider universe. These are profound questions that we simply cannot answer today. But the ancient story of IC 1101 reminds us with gentle authority that the universe operates on vast time scales that completely dwarf our individual lives, our proud civilizations, and even our entire planet. Let us now return to the quiet question of exactly what IC 1101 teaches us about our small, fragile place in the wider universe. When you step outside into the cool night and look up at the vast tapestry of stars, it is incredibly easy to feel entirely small, isolated, and completely insignificant in the face of such overwhelming, silent vastness. But I deeply believe that the simple existence of IC 1101 actually tells us something profoundly hopeful, beautiful, and comforting about our shared human situation. First, I invite you to consider the remarkable fact that we can know about the existence of IC 1101 at all. Here sits an ancient galaxy resting more than 1 billion light years away in the deepest dark, containing a staggering 100 trillion stars, and yet a young, fragile species living on a small rocky planet has successfully figured out exactly how big it is, how it slowly formed over eons, and what immense monster lies dormant at its deep center. That realization is truly, absolutely remarkable. Human beings, living our brief lives on a small rocky world that gently orbits an ordinary star in an unremarkable, quiet corner of an average spiral galaxy, have somehow developed the beautiful ability to comprehend objects so unimaginably far away that their light left before complex life even existed on our Earth. This profound ability to investigate, to understand, and to appreciate is absolutely not nothing. In a vast, silent universe composed of mindless matter and raw energy, of simple particles bouncing around according to physical laws, somehow here on Earth, deep consciousness has miraculously emerged. We possess minds that can actively wonder, ask questions, investigate the dark, and learn. Whatever else we might be, we are unequivocally the beautiful part of the universe that has finally woken up and started asking deep, existential questions about its very own nature. Second, let us gently consider that IC 1101, for all of its staggering, monstrous physical size, is made of the exact same basic physical stuff that we are. The countless stars shining within its vast body are massive nuclear fusion reactors, operating exactly like our own warm sun. They burn hydrogen into helium and slowly forge heavier chemical elements in their deep cores, just as stars do everywhere throughout the cosmos. The microscopic atoms resting in those incredibly distant stars are the exact same kinds of atoms that make up our own physical bodies: carbon, oxygen, nitrogen, and iron. Every single one of them was carefully forged in the hot hearts of ancient stars somewhere in the universe, just as the atoms in our bodies were forged in dying stars that exploded long before our sun was born. There is a beautiful, unbroken continuity here, a profound physical connection between us and absolutely everything else in the cosmos. We are absolutely not separate observers looking at the universe from the outside. We are an intimate, connected part of it. The exact same physical processes that painstakingly built the giant IC 1101 built us as well. The exact same ancient atoms that shine in those incredibly distant galaxies shine in our own eyes as we look up. We are quite literally the universe observing and contemplating itself from within. Third, let us gently consider what it truly means that giant galaxies like IC 1101 can exist at all in our cosmos. The universe did not have to be structured this way. If the fundamental physical constants of our universe were even slightly different, if the invisible force of gravity were just a little bit stronger, or the strong nuclear force a little bit weaker, stars and galaxies might never have been able to form at all. The infant universe might have simply collapsed back on itself moments after the Big Bang, or expanded so incredibly fast that matter could never clump together under gravity. Instead, we live in a universe where the physical laws are beautifully, delicately balanced to allow for the formation of stars, planets, galaxies, biological life, and conscious minds. IC 1101 stands as a magnificent, silent testament to exactly what is possible in such a beautifully tuned universe. It is a physical proof that simple matter and energy, patiently following basic physical rules over billions of years of deep time, can organize itself into structures of staggering, breathtaking complexity and quiet beauty. If our universe is fully capable of producing a giant like IC1101, what other magnificent wonders might exist out there in the dark that we have not yet discovered? What other beautiful secrets are waiting for our telescopes to find? This brings us directly to the absolute core of our quiet quest to understand the vast universe. Every single discovery we make, every distant galaxy we carefully study, and every sleeping black hole we observe gracefully expands our human sense of what is truly possible in reality. A few short centuries ago, human beings honestly believed that our Earth was the static center of absolutely everything. Then we slowly learned that we orbit our warm sun. Then we discovered that our sun is merely one single star among hundreds of billions in our home galaxy. Then we discovered that our galaxy is merely one among trillions of others scattered throughout the vastness of space. Each step in this long journey of discovery has made us seem physically smaller, yes, but it has also made our universe seem vastly grander, more deeply interesting, and infinitely more worthy of our respect and awe. IC 1101 is simply another beautiful step in that endless journey of discovery. It gently challenges us to keep asking questions, to keep looking further into the deep night, and to keep pushing the boundaries of what we currently know. And it serves as a beautiful, comforting reminder that for all of our physical insignificance on the vast cosmic scale, we are the ones doing the asking, the looking, and the pushing. In the face of its enormity, we can choose to feel small, or we can choose to feel wonder. I choose wonder. As we gracefully continue our gentle journey through the infinite cosmos, I want to quietly share with you a profound story about exactly how we human beings came to understand the true, staggering vastness of the dark sky. There is a famous, breathtaking photograph carefully called the Hubble Deep Field, which was patiently taken by dedicated astronomers in the remarkable year of 1995. The magnificent Hubble Space Telescope was intentionally pointed at a tiny, seemingly completely empty patch of the dark night sky, an area roughly the exact physical size of a single grain of sand held out at arm's length against the absolute blackness of space. To the unaided human eye, there was absolutely nothing there, just the quiet, unbroken void. But the telescope rested there in the deep silence, and it carefully gathered ancient light from that tiny, dark patch for over 100 quiet hours. What the resulting image beautifully revealed to our searching minds was absolutely astounding and permanently changed our perspective on reality. That tiny, seemingly empty patch of dark sky contained about 3,000 entire galaxies, each one a magnificent island universe containing billions of ancient stars. Since that miraculous moment of revelation, Even deeper and more profound images have been patiently taken by our scientists. The Hubble Ultra Deep Field, the Hubble Extreme Deep Field, and most recently, the breathtaking images from the James Webb Space Telescope have beautifully revealed ever more ancient galaxies hidden in ever smaller patches of the night sky. The philosophical conclusion derived from these incredible images is completely inescapable and deeply humbling. Everywhere we look into the dark, no matter exactly how small the physical area of sky we choose to observe, we find sweeping, ancient galaxies. The universe is completely filled with them, perhaps 2 trillion in total, gracefully spread across billions of light years, in every single conceivable direction in the dark. IC 1101, the sleepy giant we have been contemplating, is truly just one of those 2 trillion distant galaxies. It is an exceptional one, yes, larger and vastly more massive than almost all the rest, but it is still simply just one single galaxy existing among countless billions floating in the cosmic ocean. The wonderful fact that we have singled it out, carefully studied it, and slowly come to understand it is a profound testament to human curiosity and our relentless ingenuity. But we could have gracefully chosen almost any galaxy in that deep image and found hidden wonders just as remarkable. The universe is incredibly generous with its ancient marvels, endlessly offering new mysteries to any mind quiet enough to ask. I also deeply want to reflect on what it truly means to securely know something about IC 1101 that absolutely no human being knew just a few short centuries ago. The brilliant astronomer William Herschel, when he first spotted this distant object in the year 1790, could have had absolutely no true conception of what he was actually looking at through his glass lens. He simply saw a faint, fuzzy blob of light resting in the dark. We, on the other hand, look at that exact same spot and beautifully see a staggering 100 trillion burning stars, an unfathomable 50 billion solar mass black hole, and billions of years of silent, violent cosmic history perfectly preserved in the light. The profound difference between his early understanding and our modern comprehension is almost as completely vast as the physical distance to IC 1101 itself. This beautiful progress in our shared understanding absolutely did not happen automatically or overnight. It required the dedicated, lifelong work of countless individual minds, contributing their tiny, necessary pieces to the grand puzzle. Passionate astronomers who built bigger and better telescopes, theoretical physicists who worked out the complex theories of ancient light and heavy gravity, brilliant engineers who meticulously designed delicate satellites and sensitive instruments, and quiet mathematicians who carefully developed the complex tools necessary to analyze oceans of data. Each successive generation beautifully built upon the foundational work of those who came before them, gradually and patiently constructing the grand edifice of scientific knowledge that miraculously allows us to comprehend objects resting 1 billion light years away in the dark. When you gently think about IC 1101 today, you're absolutely not just thinking about a distant galaxy. You are actively participating in a grand, ancient tradition of philosophical and scientific inquiry that seamlessly stretches back across the centuries. You are quite literally standing on the shoulders of giants. As the great scientist Isaac Newton once famously and humbly said, if he had seen farther than others, it was only by standing on the shoulders of giants who preceded him in the quest for truth. The profound understanding of IC 1101 is absolutely not the exclusive property of any single individual or nation. It beautifully belongs to humanity as a whole. a shared precious heritage of knowledge that completely transcends any single person, any single culture, or any single language. There is something deeply, fundamentally democratic and unifying about this cosmic realization. Astronomical knowledge is beautifully available to absolutely anyone who genuinely wants it. You absolutely do not need to be wealthy or powerful to learn about the deep mysteries of IC 1101. The information is peacefully out there in quiet books, detailed articles, and meditative videos like this one, patiently waiting for absolutely anyone curious enough to seek it out. The ancient universe generously reveals itself to anyone who humbly asks the right questions. I find this particular thought incredibly encouraging and deeply peaceful. In a human world that very often seems terribly divided and contentious, the shared, peaceful pursuit of cosmic knowledge is something that beautifully unites us all. It absolutely does not matter what country you come from or exactly what human language you speak. The ancient stars shine perfectly equally for everyone, and the scientific truth about IC 1101 is the exact same truth everywhere across our planet. Science, at its absolute best, is a beautifully cooperative endeavor that seamlessly brings diverse people together across all the artificial boundaries that usually separate us in our daily lives. Let me also gently say something vital about the profound concept of wonder. Throughout this entire quiet exploration of IC 1101, I have earnestly tried to convey to you not just cold facts, but deep, resonant feelings. The scientific fact that IC 1101 is 4 to 6 million light-years across is intellectually interesting, but the profound feeling of awe that this physical fact naturally produces in the human heart is something vastly more important. It is a holistic experience, a meditative state of mind, a beautiful way of deeply engaging with the cosmos that goes far beyond mere intellectual understanding. True wonder is very often mistakenly dismissed in our modern society as something childish, something we are mistakenly supposed to outgrow as we sadly become serious adults burdened with serious earthly concerns. But I deeply believe that retaining our sense of wonder is absolutely essential to living a good, meaningful life. It beautifully opens our minds to gentle experiences far beyond the mundane everyday. It peacefully reminds us that there is vastly more to our existence than our immediate, fleeting problems and temporary pleasures. It perfectly connects us to something unimaginably larger than our fragile selves. IC 1101 is a perfect, beautiful occasion for pure wonder. 100 trillion stars, 4 to 6 million light-years of distance, 1 billion years of continuous light travel time, a silent, supermassive black hole containing 50 billion solar masses. These are staggering numbers so incomprehensibly large they actively strain the limits of human comprehension. These are physical distances so unimaginably vast they completely beggar our earthly imagination. If you can quietly contemplate these massive things without feeling a deep, resonating sense of cosmic awe, I am not entirely sure what would ever move your heart. But experiencing deep wonder absolutely does not require complete scientific understanding. You can feel genuine, profound wonder at the sheer existence of IC 1101, even if you do not completely grasp all the complex physics and mathematics behind it. The overwhelming sense of vastness, the quiet confrontation with scales far beyond human experience, the beautiful realization of exactly how much exists beyond our small world, these are peaceful experiences available to absolutely anyone who takes the gentle time to really think about what we have discussed together. The discipline of science beautifully enhances our wonder by carefully revealing the intricate specifics of reality. But the deep feeling of wonder itself is a fundamentally human response to the terrifying immensity of cosmic creation. That is the true underlying wonder of all science, and of astronomy in particular. It is absolutely not just the ancient objects we carefully study, magnificent as they truly are, but the miraculous fact that we can actually study them at all. It is human consciousness looking out at the vast, silent cosmos and miraculously making logical sense of what it sees. It is ancient matter finally understanding itself. As the renowned and beloved astronomer Carl Sagan beautifully observed in his teachings, we are made of star stuff. And as the brilliant astrophysicist Neil deGrasse Tyson so often reminds us, we are not simply living in the universe, but rather the universe is actively living within us. These are not merely poetic metaphors. They are the absolute, literal, scientific truth of our very existence. I want to leave you with one final, deeply profound thought to hold in your heart. The physical atoms currently resting inside your living body were painstakingly forged in the incredibly hot cores of ancient stars. The vital carbon that structurally makes up your muscles, the precious oxygen you quietly breathe into your lungs, the heavy iron that runs through your warm blood, all of these essential elements were physically created in the massive nuclear furnaces at the deep cores of ancient stars that lived and violently died long before our own sun was ever born. When those ancient massive stars spectacularly exploded as supernovas in the dark, they violently scattered their elemental riches across the vast, empty space. Eventually, over deep time, some of those wandering atoms found their quiet way into a cold cloud of gas and dust that eventually collapsed under gravity to beautifully form our solar system. They miraculously became the Earth. And then, after billions of years of slow, patient evolution, they miraculously became you. You are quite literally made of star stuff. This is not just lovely poetry. It is the fundamental chemistry of the cosmos. The very same physical processes that brightly light up IC like 101's 100 trillion ancient stars has also painstakingly created the very matter from which you are perfectly assembled. There is a direct, undeniable physical connection between your breathing body and those incredibly distant cosmic fires. In a very real, scientifically accurate sense, when you quietly sit in the dark and contemplate the majestic beauty of IC 1101, you are ancient star stuff peacefully contemplating more ancient star stuff. The universe is finally looking at itself through your eyes, trying to deeply understand exactly what it is and exactly how it came to be. We are absolutely not separate from the vast cosmos we study. We are an intrinsic, beautifully connected part of it, and our human curiosity is quite simply the cosmos being curious about its own nature. The sleeping giant IC 1101 will absolutely never know that we have successfully discovered it, resting in the dark. Ancient galaxies absolutely do not possess conscious minds or subjective experiences, but we do know, and in knowing this profound truth, we beautifully complete a cosmic circuit that intimately connects human consciousness to the staggering grandeur of the infinite. We are incredibly tiny, yes. Our individual lives are incredibly brief, yes. But in the brief, beautiful moment of our conscious existence, we can miraculously reach out with our minds across 1 billion light years of cold space and gently touch the absolute largest galaxy ever discovered by humanity. That intellectual reach is our true human glory. It is the quiet triumph of consciousness over the terrifying silence of the void. And as we prepare to draw our final conclusions about the deep nature of reality, about what forces shape the universe, and about what this means for our inner peace, We must carry this profound realization with us into the dark. The universe is entirely within us, and we are entirely within the universe, bound together in an eternal, silent dance of gravity, light, and wonder. The deepest mysteries of existence are not found solely by looking outward into the endless night, but by understanding that the very mind doing the looking is the greatest cosmic miracle of all. When you next step outside into the cool night and gently look up at the vast sweeping tapestry of the dark sky, I want you to peacefully remember the sleeping giant IC1101. You absolutely cannot see it with your unaided human eyes. It is far too incredibly distant and vastly too faint for our limited vision to capture. But it is undeniably there, resting quietly in the direction of the constellation Virgo, shining silently with the ancient light of 100 trillion burning stars. It has been there for billions of years, a silent witness to the unfolding cosmos, and it will steadfastly remain there for billions of years more into the deep future, long after our own warm sun has completely burned out, long after our fragile Earth has been gently consumed by an expanding red giant. IC1101 will still be there, slowly and beautifully fading into the eternal cosmic night, but absolutely not yet gone. When we ask the profound ancient question of what the ultimate creator truly is, we are very often looking for a reflection of our own human faces in the dark. But the silent, majestic reality of the cosmos beautifully suggests something vastly more profound, infinitely more mysterious, and deeply comforting. If the divine is simply the ultimate, inescapable truth of reality, the absolute foundation of all existence, then it is perfectly written in the beautiful, unbreakable laws of physics that gently govern everything from the smallest falling atom to the staggering mass of IC1101. It is the ancient, invisible gravity that patiently pulls dust into brilliant stars and beautiful galaxies into colossal clusters. It is the deep, silent river of cosmic time that allows magnificent complexity to slowly bloom from primordial simplicity. The universe is absolutely not the small, comfortable, earth-centered dome we once confidently thought it was. It is a vast, ancient, and beautifully indifferent ocean of energy and matter, and within that profound indifference lies our ultimate intellectual freedom and deep inner peace. We are not the absolute center of the cosmos, but we are its brilliant, conscious awakening. We are an intrinsic part of a sweeping, endless universe that naturally contains such staggering wonders. We are entirely made of the exact same star stuff as IC1101's 100 trillion ancient stars, formed by the exact same physical processes, and completely governed by the exact same universal laws of physics. In carefully studying that distant, fading giant, we profoundly learn about ourselves and our quiet place in the grand, sweeping story of cosmic evolution. The absolute biggest galaxy we have ever successfully discovered is undeniably bigger than your earthly imagination. But the profound, beautiful fact that you can actively imagine it at all, that you can peacefully hold in your small human mind a vivid picture of 100 trillion ancient stars perfectly spread across millions of light years, that you can actively wonder about its violent past, its lonely future, and its potential silent inhabitants, that is perhaps the absolute most amazing and miraculous thing of all. When we fully surrender to the staggering scale of a galaxy like IC1101, something miraculous happens to our everyday worries, the small earthly anxieties that normally consume our waking hours, the minor conflicts, the fleeting stresses, the daily struggles, begin to gently dissolve in the face of the infinite. This is absolutely not to say that our brief human lives do not matter. They matter profoundly, because consciousness is the rarest and absolute, most beautiful jewel in the entire cosmos. But the cosmic perspective gracefully lifts the heavy burden of earthly perfection from our tired shoulders. If the universe can effortlessly orchestrate the silent collision of entire galaxies over billions of years, if it can patiently birth 100 trillion stars and watch them slowly fade into the dark without a sound, then surely we can find the quiet grace to forgive ourselves for our small, human imperfections. We are merely young children of the cosmos, just beginning to slowly open our eyes and make logical sense of the immense, ancient house we briefly inhabit. To quietly contemplate the true, hidden nature of reality is to deeply engage in the absolute, most ancient and sacred human tradition. For countless thousands of years, our curious ancestors sat around warm fires in the terrifying dark, looking up at the very same ancient stars, weaving beautiful myths and colorful legends to try and explain the profound mysteries floating above them. They desperately sought comfort and safety in the face of the vast unknown. Today, we beautifully use magnificent space telescopes, complex mathematics, and rigorous scientific observation to peer deep into that exact same dark. Our human stories have inevitably changed, gracefully becoming grounded in absolute, testable reality. But the underlying human impulse remains exactly the same. The rigorous scientific facts we have carefully gathered about the universe are vastly more staggering and beautiful than absolutely any myth our ancient ancestors could have possibly imagined. The undeniable truth of IC 1101, a cosmic behemoth forged by billions of years of silent gravitational cannibalism, possessing a central black hole that could easily swallow our entire solar system without leaving a single trace, is a profound story that inspires a level of respectful awe that borders on the truly religious. But this modern scientific sense of awe is entirely free from earthly fear or rigid dogma. It beautifully provides an intellectual safety that softly invites you to question absolutely everything you see. When we gently say that the universe is absolutely not what you think, we are merely inviting you to let go of your rigid, earthly preconceptions. The vast cosmos is absolutely not a static, finished product designed merely for our temporary comfort. It is a wildly dynamic, eternally evolving physical process, an endless river of deep time and vast energy that silently flows without absolutely any concern for our brief human timelines. And yet, this profound cosmic indifference is precisely what makes our fleeting existence so incredibly, breathtakingly special. In a universe entirely governed by cold physical laws and mindless ancient forces, the simple, beautiful fact that you can actively experience love, curiosity, wonder, and deep inner peace is an absolute cosmic miracle. You are the vast universe briefly experiencing the profound warmth of its own existence. You are the silent cosmos gently whispering its own beautiful name into the eternal dark. Consider once more the quiet, unbroken silence of deep space. It is a profound, meditative silence that perfectly cradles the absolute most violent cosmic events imaginable to the mind. While supermassive black holes violently merge and release vastly more energy than billions of burning stars, the ancient universe remains entirely, peacefully quiet. This cosmic silence is a powerful, beautiful metaphor for the deep inner peace we can all actively strive to gracefully cultivate within ourselves. Even when our personal earthly lives feel incredibly chaotic and completely overwhelming, very much like massive galaxies violently colliding in the dark, we can gently retreat to the quiet, safe center of our own human consciousness. we can peacefully find a safe place of absolute stillness within, a silent, mindful observer that merely watches the swirling storms of earthly emotion and anxious thought without ever being consumed by them. We gracefully learn to become the calm, quiet center of our own internal universe, perfectly anchored by the profound understanding that absolutely everything is beautifully transient, everything is gracefully evolving, and absolutely everything is ultimately connected in the grand, sweeping cosmic dance, the ultimate peaceful realization of exactly what the cosmic architecture truly represents. The undeniable, infinite majesty of pure creation is perhaps the closest our human minds can ever possibly come to truly understanding the divine in reality. It is absolutely not a mythical figure passing earthly judgments from above. It is the breathtaking, elegant mathematics of a black hole's silent event horizon. It is the majestic, incredibly slow rotation of a beautiful barred spiral galaxy floating in the void. It is the ancient, whispering light that has continuously traveled for over 1 billion years just to softly touch your waiting eye. It is the profound, unbreakable physical unity of absolutely all things, stretching from the absolutely smallest vibrating quantum particle to the largest, most massive supercluster of ancient galaxies resting in the deepest dark. When you finally, fully comprehend this beautiful scientific truth, you peacefully realize that you're absolutely never, ever alone. You are intimately, permanently connected by the laws of physics to every single star that has ever burned and every single planet that has ever miraculously formed. You completely belong to the grand universe, and the ancient universe completely belongs to you. As we slowly prepare to part ways for tonight, I want to gently thank you from the absolute bottom of my heart for joining me on this profound, peaceful journey through the absolute biggest galaxy ever discovered by humanity. If this quiet, meditative video truly helped you gently see the vast ancient universe in a completely new, beautiful way, please thoughtfully consider leaving a quiet comment below, simply letting our growing community know exactly what you deeply think about our quiet, brief place in a cosmos that patiently contains such magnificent, silent wonders. Your unique, personal perspective beautifully enriches our shared human understanding of the infinite. And if you genuinely want to keep peacefully exploring the deep, ancient mysteries of the amazing universe with us, please absolutely do not forget to gently like this video and beautifully subscribe to our channel. We are actively building a beautiful, safe community of curious cosmic explorers right here, and your quiet presence makes our shared human journey all the vastly more meaningful and profoundly special. Until we peacefully meet again in the gentle dark, I warmly invite you to just keep looking up at the ancient, shining stars. Keep gently feeding your beautiful curiosity, and keep endlessly wondering about the infinite, silent mysteries that beautifully wait for us all in the eternal cosmic night.